They took me on a Tuesday, or what passed for Tuesday, out past the Keth Dorvani relay cluster. The ship's clock said 3:40, and I was asleep in my bunk when the survey scout went dark, and something very large and very quiet put a tractor field around us that the hull didn't argue with. I want to be clear about what I mean when I say the hull didn't argue. The Keth Solon IV is a Class C deep survey platform with active shielding rated to handle impact events up to Tier 7. Whatever put that field on us, the shield package looked at it, did a quick professional assessment, and went home. I found out later the field had been on us for about 40 seconds before I even registered the change in the vibration through the frame. That's what woke me, actually. Not an alarm. Not the red band proximity alert that should have fired as something large mass came within intercept range. A change in the hum, the baseline resonance of the hull under normal transit conditions, shifting maybe 3%, which is the kind of thing you notice when you've lived on survey platforms for 11 years, and you've learned to read the ship the way a farmer reads the weather. The quality of silence has texture. When the texture changes, you're already awake before you've decided to be. I sat up. The cabin was dark and the emergency lighting wasn't on, which told me the hull was intact and the power systems were nominal. The systems weren't alarmed. They just weren't doing anything. The vibration through the bunk frame was wrong, too smooth, too even, as if the scout had stopped fighting its own passage through space, and something else was providing the trajectory. I put my feet on the deck and stood up and looked out the cabin porthole at a section of dark that was darker than the surrounding dark and had a surface to it. I have a ration bar in my cargo pocket at all times. This is a habit from the secondary, where you learn early that the difference between a bad situation and a catastrophic one is often whether you have calories on your person when conditions change without notice. I retrieved it, broke it in half, ate the first half, put the second half back, and waited to see what happened next. My name is Myra Das. I hold a senior geological survey license through the Keth Voren Contractors Collective and a Class B exoplanet assessment certification, which takes 6 years and 3 full field rotations to acquire. I was born on Veth Coral Secondary, which is a Class 14 Deathworld in the outer corridor survey zones, which I mention only because it becomes relevant later in ways I couldn't have predicted when I was floating in that tractor field eating half a ration bar in the dark. Class 14 means what it means. The gravity on the secondary runs 1.31 standard at sea level and goes up from there as you move inland toward the elevated plateau sectors, where most of the interesting geological work is. The atmosphere is breathable, but the pressure differential between the coast and the interior generates storm systems that can sustain 200 km/h winds for weeks at a stretch. And the tectonic activity in the eastern belt means you work to a background noise of the ground doing something unexpected at irregular intervals. The flora runs aggressive in the chemical sense, not predatory, but producing compounds that most off-world species find corrosive at contact, which means your field gear wears out faster than the manufacturer's specifications suggest, and you learn to treat your skin barrier seriously. The fauna is what it is. I won't itemize it. The point is that I spent the first 18 years of my life on the secondary, and then 11 more years on survey rotation in environments that were generally rated between Class 11 and Class 16, depending on the specific contract. I have been in 2 hull breaches, 1 uncontrolled atmospheric reentry in an emergency evac pod, which is as bad as it sounds and also educational. A 6-week survival situation on a glaciated moon after a survey team's ground transport failed in a storm season, and we had to make do with what we had on our persons and what we could improvise from the transport wreckage, at temperatures that my team's 2 off-world members found genuinely life-threatening, and that I found challenging but manageable. I do not have a dead family. I have no tragic backstory to explain why I am the way I am. I grew up somewhere hard, I worked hard places for 11 years, and the result is that my general attitude toward adverse events is, Assess the situation, identify what you can affect it, and eat something if the opportunity presents. The tractor field was an adverse event. I was eating. The examination bay was clean. That was my first note when they brought me aboard, because geological surveyors are trained to read environments, and my eyes were gathering data before I'd fully processed where I was. Every surface was a neutral blue-gray composite that I couldn't immediately identify. Not metal, not polymer, somewhere between the two, with a surface texture that didn't quite match anything in my material experience. It had the density reading of a ceramic but the acoustic properties of something with more internal structure, and the seams between panels were fitted with a precision I estimated at under 0.5 millimeter. Whatever this was, it was built well and maintained carefully. The lighting was even and sourceless, which is a genuinely difficult engineering problem. Light from a point source produces shadows. Light from a diffuse source produces a quality of illumination that's easier to work in but harder to generate without visible infrastructure. The light in this room came from the wall-ceiling junction through a material I couldn't identify, diffusing without seam or source point. I noted that and filed it for later. Temperature was 19 degrees Celsius, which I appreciated unreservedly. The gravity was slightly under one standard. I estimated 0.95, maybe 0.93, which was comfortable. Standard on Veth Coral Secondary is 1.31, and 11 years of working in varied gravity environments had left my musculoskeletal system with a range of tolerances rather than a fixed preference, but 0.95 was where I felt genuinely at ease. I stretched my shoulders, which had been doing something odd in the tractor field, and looked around. The Kethsorvani were already in the room, 3 of them, positioned at intervals along the far wall in a formation I recognized as behavioral observation positioning, 1 central, 2 flanking, all with unobstructed sightlines to the center of the space where I was standing. They were about 2 meters tall, and their surface was chitinous in a way that caught the sourceless light differently at different angles, a matte, segmented blue-black that went iridescent at the edges under direct illumination. 6 limbs, the upper 4 articulated for fine manipulation, each terminating in a 3-digit manipulator arrangement with what appeared to be significant grip force capability based on the joint structure. The lower 2 serving as primary locomotion, digitigrade stance, quiet. Compound eyes arranged in a lateral array that gave them, I estimated, close to 280 degrees of passive visual coverage. Mandibles that moved when they communicated. And a sound in the low frequencies, below comfortable hearing range, something I felt as much as heard, a background vibration that modulated as they processed whatever was happening between them. I have seen stranger things on survey rotations. I spent 8 days camped on the rim of a hydrothermal system on a tidally locked moon, where the local fauna ran to 6-meter chemosynthetic tube forms that communicated by pressure wave through their immediate substrate, and had a distributed nervous system with no central processing node, which means you couldn't locate the thing's decision-making architecture, because it didn't have one in the sense I usually meant. The Kethsorvani were bilateral, locomotion stable, bilaterally symmetric in their limb arrangement, and clearly operating within a command structure. One of them had a different posture from the other 2, more central, more forward, a fractional orientation difference that read as authority. I could work with a command structure. I knew how to behave around one. "Hello," I said, because it seemed like the appropriate starting position when you've just been put in a room with entities you haven't met before. The central examiner made a series of sounds, and the room's translation matrix, a thin panel in the ceiling that I hadn't noticed until it activated, its frequency management mechanism producing a slight pressure change in my sinuses as it calibrated, produced a flat mid-register approximation of. Specimen will proceed to the assessment platform. The assessment platform was a raised surface in the center of the room, approximately table height, with a contour clearly designed for a reclining body. The contour was wrong for me. I could see that before I got on it. It had been shaped for a body with a longer torso-to-limb ratio than mine, more pronounced spinal curvature in the upper thoracic region, and a different mass distribution around the central axis. Probably something dorso-ventrally flattened relative to my configuration. I climbed on, assessed the contact points, and adjusted my position to distribute them more evenly. The platform was designed for a different body plan, I said, once I'd found an arrangement that wasn't uncomfortable. About 15% longer torso relative to limb ratio, I'd estimate, and the upper thoracic curvature support is built for a spinal geometry I don't carry. You might want to note that for recalibration if you're going to run more bilateral symmetric specimens through here. The contact point distribution affects the structural assessment results. The translation matrix rendered this. The central examiner's mandibles moved. The two flanking examiners moved fractionally closer together, a postural shift so small I might have missed it if I hadn't been watching for exactly that kind of thing. Something in the register of unexpected. I noted it and set it aside. The examination began. Stage 1 was structural assessment. The instruments came down from recessed housings in the ceiling, articulated arms with sensor heads at their tips, directed by the examiners with what I recognized as practice precision. They had done this before, many times, and they were good at it. The sensor heads moved over my body in a systematic grid pattern that reminded me of the magnetometric survey passes I run over geological formations. The same logic of complete, overlapping coverage, no gaps, a record built incrementally until the picture was complete. I held still and let them work, which seemed like the cooperative and sensible thing to do. The first disruption to their rhythm came when the central examiner ran the sensor heads over my sternum and reviewed the output. I couldn't see the displays. They were positioned at the examiner station, facing away from me, which was probably standard practice for obvious reasons, but I could read the behavioral response. The central examiner made a short sound in the mid-frequency range, and one of the flanking examiners immediately moved to review the display alongside them. Then they reran the sensor pass, this time focusing on my sternum and both forearms. I have above-median bone density for a human, which is already an outlier relative to most surveyed species from lower gravity environments. 11 years of heavy labor survey contracting in variable gravity, plus 3 field rotations on Veth Coral Secondary at 1.31 G, adds load adaptation that pushes that number further. My baseline bone density in the load-bearing structures runs approximately 35 to 40% above what standard human reference data shows, because standard human reference data is assembled from humans in standard gravity environments who don't spend their working lives walking across geological formations in high-G conditions, carrying 40 kilos of survey equipment. The secondary pass over my forearms took 4 minutes. I waited. "Is the reading outside your instrument's calibrated range?" I asked. The central examiner looked at me. "The specimen is within parameters," it said, and I was nearly certain that was not accurate. "I should tell you I'm Class 14 origin," I said, "Veth Coral Secondary. The standard human baseline in your reference data is probably assembled from Class 6 through Class 9 populations, which would put it 30 to 40% below my numbers in the load-bearing structures. You might need an adjustment factor rather than a recalibration. The instrument is probably right. It's just reading against the wrong baseline." There was a pause that was about 3 seconds longer than any previous pause had been. The two flanking examiners conferred in the low-frequency register I couldn't quite hear. The central examiner returned to the display, made several adjustments I couldn't see, and reran the sternum pass again. They were at it for 11 minutes. I used the time to continue my assessment of the room. The ceiling panel housings for the instrument arms were recessed with that under 0.5 millimeter tolerance I'd noted earlier. This was a consistent standard across the whole bay, not just the sections I'd first looked at. The floor material was different from the wall composite, harder, more uniform, slightly higher albedo under the sourceless light, which suggested something denser and more impact-resistant, probably because a floor takes more varied load stress than a wall does. The platform I was sitting on was a third material, and the join between the platform base and the floor was sealed with something that had given slightly when I put my weight on the edge on the way up, not flexible, but not perfectly rigid either. That was interesting. Impact absorption built into the join. Someone had thought carefully about what happens when a specimen of uncertain mass sits down quickly. Stage 2 was cardiovascular and respiratory mapping. The sensor heads relocated and I recognized the pattern, heart rate, blood pressure, respiratory mechanics, the basic circulatory architecture. I breathed normally and let the instruments run. My resting cardiovascular output is high for a surveyor, even by human standards. The secondary does that, and 11 years of fieldwork compounds it. My resting heart rate runs about 62% above what standard human reference data predicts for my age and frame. My blood pressure is elevated in the same proportion. The system is functioning correctly. It's just calibrated for a different operating environment. This produces interesting conversations with physicians from standard gravity populations, who review my numbers without the contextual baseline, and conclude I'm in cardiac distress when I'm eating breakfast. I watched the central examiner stop the scan about 40 seconds in, review the output, and restart it. My cardiovascular numbers tend to run about 40 to 60% above what the standard human baseline reports would show, I said. Survey work at 1.31 G for an extended period recalibrates the whole system. If your reference data is from humans in standard gravity environments, the readings will look like an active stress response, but this is my resting baseline. I'm not distressed. I've been sitting still for 20 minutes. The flanking examiners both looked at me this time. The postural shift was more pronounced than the earlier one. Both upper limb pairs angled slightly downward, a postural compression that I decided to categorize as processing effort. You have a reference sample for human specimens? I asked. The Directorate maintains assessment records for all surveyed species, the central examiner said. How many humans have you processed? A pause. 17. I thought about that. What class were they from? The central examiner checked its station. Standard survey designation, class 6 through 9. That explains the gap, I said. Class 14 physiology is a different distribution on almost every measurable axis. The bone density difference I mentioned, the cardiovascular calibration, the sensory range, they all shift in the same direction, which is upward from what class 6 through -9 shows. If it would help, I can give you a rough description of the adjustment factors for each category as we go through them. Your data will be more interpretable with the correct baseline. The central examiner's mandibles moved for approximately 4 seconds without producing translation matrix output. One of the flanking examiners moved back to the original observation position. The other stayed near the display. The assessment will continue, the central examiner said. Of course, I said. I was just trying to be useful. Your data is more accurate if the baseline is correct, and a more accurate record serves your purposes better than a systematic misread. Stage 3 was neurological and sensory response mapping. They ran a sequence of stimuli, light, sound, pressure, temperature variation, and monitored the neural response pattern. It was methodical and well sequenced. The light went first, stepping through the visible range in frequency increments I estimated at about 5 nanometers, and the sequencer ran up into frequencies where it apparently expected my response to drop off. I could still detect it clearly. The central examiner stopped the sequence, conferred with the flanking examiners, and ran the upper range again. Your visible detection range extends further than this, the central examiner said. into the near-ultraviolet, about 30 nanometers past what most of your reference species probably show, I'd guess, based on where the sequence paused. It's a secondary origin trait. The UV index on Veth coral secondary is high enough that detecting into that range was useful information for the organisms that evolved there. I can give you an approximate nanometer estimate if you want to calibrate your sequencer, but I'd need to know what frequency you're currently marking as the top of the range. The central examiner told me. You can push it about another 35 nanometers before I lose it, I said. Give or take 5. After that it drops off quickly. They pushed the sequence. The estimate was accurate to within 3 nanometers, which I was quietly pleased about, though I didn't say so. The sound sequence ran through subsonic and into ultrasonic, and I detected the subsonic components further down the frequency range than their reference data apparently predicted, which produced another pause and another reconsultation at the display station. The temperature probe, a contact sensor applied to the back of my right hand with a pressure that told me it had significant thermal range, ran from approximately 4 degrees Celsius downward. The central examiner stopped it at what I estimated was about 0 degrees and said, "The pain response signal is below threshold." "I'm not feeling pain," I said. "At the current temperature, the standard pain response cascade for soft tissue specimens should be active." "What's the threshold temperature for your cascade marker?" The central examiner told me. It was approximately 6 degrees above where they'd stopped. "I don't hit a strong response until about -8, -10, I said. "Field work in sub-zero environments extended. You adapt. The cold tolerance is partly secondary origin. The plateau winter seasons run well below 0, and partly 11 years of working in cryogenic range environments on survey contracts. My tissue doesn't signal distress at temperatures that would alarm a standard gravity human, because I've spent a lot of time at those temperatures, and they're not novel enough to warrant the alarm. It's the same recalibration mechanism as the cardiovascular numbers. The system adjusts to what it actually encounters." I paused. "What's your cascade marker protocol after this stage? Do you run a pressure sensitivity sequence next, or is that a separate stage?" The 3 Kethsorvani all became very still at the same time. Not the stillness of observation, something different in the quality of it, a suspension that preceded a decision rather than accompanied one. "The assessment stages are not communicated to specimens," the central examiner said finally. "I'm not trying to interfere with your protocol," I said. "I'm curious about the sequence logic. It's a coherent assessment structure. You're doing structural first, then cardiovascular, now sensory response, which makes sense because the structural data gives you a baseline for interpreting the cardiovascular load, and the cardiovascular baseline helps you normalize the sensory response cascade. I assume stage 4 is going to be something around stress response or cognitive function, because that's what the data gathered so far would set up. I'd guess cognitive, actually, because the sensory stage feeds the cognitive assessment better than the stress assessment. You need the sensory range data to design a valid stress stimulus for stage 5. Stage 4 cognitive, stage 5 stress, stage 6 probably endurance or physical capacity, and then something around adaptation and communication at the end. Am I close? A long silence. The subsonic communication channel activated. I could feel it in my chest, a resonance that came and went in patterns I was starting to be able to distinguish even if I couldn't interpret them. "You have undergone assessment protocols before," the central examiner said. "No," I said, "but I've designed survey assessment protocols for geological and biological fieldwork for 11 years. The logic is the same. You're building a picture layer by layer, each stage contextualizing the data from the stages before it. It's good methodology. Whoever designed your protocol understood how to layer dependent information correctly." There was another pause, longer than the previous one. The methodology is standard directorate procedure, the central examiner said, and I had the impression this was not quite what it had intended to say. Stage 4 was cognitive function, as I had guessed. They ran a visual pattern recognition sequence, a spatial reasoning battery, and a working memory load test. A series of symbol sequences displayed on a panel, one of the instrument arms extended to position in my visual field, each sequence to be reproduced in a specified order after a variable delay. The symbols were in a notation system I hadn't encountered before. I watched the first 2 sequences pass without responding, then said, "These are in a notation system I don't have a reference for. I can reproduce the shape of the sequence from visual memory. That's a straight recall task regardless of whether I know what the symbols mean, or I can try to infer the underlying pattern logic if there is one. Which is more useful for your assessment?" The central examiner said, "The specimen reproduces the sequence as displayed." Understood. I'll do straight visual recall. I wanted to flag it because the performance characteristics are different depending on whether I have semantic content to attach to the shapes. Visual recall of meaningless shapes decays faster than recall of structured information with semantic content. Your baseline for this test probably assumes the specimen can read the symbols. Reproduce the sequence as displayed, the central examiner repeated. So I did that. The sequences increased in length and the delays between display and reproduction grew progressively longer, which was clearly intended to stress the working memory load. I was treating the symbols as abstract shapes. Their individual identity was irrelevant. What mattered was their position in the sequence and their relationship to adjacent symbols. This is actually a skill you develop doing magnetometric survey mapping, where you spend a lot of time looking at spatial data and learning to hold orientation relationships in memory, without being able to name the positions in any meaningful vocabulary. I ran through the sequences cleanly. Around the 12th iteration, when the delay had grown long enough that I was doing something closer to active reconstruction than straight recall, the flanking examiners changed positions. The one who had been on the left moved to the display station, and the one who had been at the display took up the flanking position, watching me instead of the readout. I took this as a monitoring escalation. "Is the performance outside expected range?" I asked, during one of the delay periods. "The assessment continues," the central examiner said. I should mention that I'm doing straight visual recall, treating the symbols as abstract shapes. If you ran this test with a notation system I could read, the performance on the longer delays would probably be better, meaning compresses storage significantly, and reconstruction from meaning is more reliable than reconstruction from shape alone for delays over about 3 minutes. The current data shows my raw visual spatial working memory, not my symbol processing capacity. If you want the latter, you'd need to run a version I could read, or build in a learning phase at the start. The central examiner did not respond. It ran the next sequence. After the 20th iteration, it stopped the sequence, and the 3 examiners consulted in the subsonic register for a period I timed at 6 minutes and 40 seconds. I used the time to examine the symbol system from the sequences I'd already seen. I had been watching for pattern while running the recall tasks, as a background process, because it's easier to hold something in memory when you're also thinking about it. The symbols were positional variants of a base set of 9 geometric elements, rotation and reflection generating the full range of variants, which was consistent across all 20 sequences. I didn't know what they meant, but the morphological logic was clear once I had enough samples. "Your base symbol set is 9 geometric elements," I said when the consultation ended. "Rotation and reflection generates the full variant range. Is the semantic content positional, relational, or both?" The central examiner looked at me for what I estimated was 8 seconds. "The specimen has derived the structural logic of the notation system," it said. This appeared to be directed at the flanking examiners rather than at me, because it said it without looking at me, and the translation matrix rendered it, but the central examiner did not wait for my response. It's a coherent construction, I said. The positional relationships are consistent across all 20 sequences. If the semantic content is relational, the sequence logic probably encodes dependency chains. The relative position would carry the meaning rather than the individual symbol. If it's positional, it's more likely indexing, where the symbol identity matters more than its relationship to neighbors. I'd guess relational, based on the density variation in the middle segments of the longer sequences, but I'd need more samples to be confident. Would you be willing to run another dozen sequences? The assessment will continue, the central examiner said. It sounded, through the translation matrix's best approximation, like something that had decided to concentrate very hard on a specific and immediate task. Stage 5 was what I had predicted, stress response assessment. The light level in the room dropped by about half. The temperature dropped. I estimated it went from 19 to about 12 in about 4 minutes. The instrument arms configured in what I can only describe as a threat posture arrangement, positioned around the platform at angles that suggested enclosure rather than examination, closer than they'd been in any previous stage, angled slightly inward. The sounds in the room changed to incorporate lower frequencies with more amplitude, and at the higher intensity levels, I could feel this as a pressure sensation in my chest, a mild vibration in the sternum. I sat up on the platform and looked at the configuration. "Is this a fear response assessment?" I asked. No answer from the translation matrix. "I'm going to describe what I'm observing, because I think the description is useful for your record regardless of whether you answer. The lighting reduction is targeting a low visibility anxiety response. Reduced visual information density is a consistent threat signal across most species. The temperature drop is targeting thermal discomfort anxiety. The instrument arm positioning is a spatial threat simulation. The enclosure geometry is designed to trigger a fight or flight cascade by making the immediate environment feel constrained. The sound frequency is targeting the visceral unease that most species carry from evolutionary threat sound response. Predator warning sounds tend to concentrate in the low frequencies, and the response to them is largely involuntary. It's a well-designed configuration. Does it usually work?" No answer. The arm position to my right moved incrementally closer. I watched it without moving. "I want to be clear that my stress response is functioning," I said. "I can feel the pressure differential from the sound frequency, and the temperature is getting into a range I find genuinely cold. I'm not failing to respond. I'm responding at a lower amplitude than your baseline probably predicts, which is different from not responding. The question is whether the response I'm producing is enough to reach whatever threshold you're measuring toward." A longer silence. The light stayed down. The temperature continued to drop. "What triggers the end condition on this stage?" I asked. "What response level are you looking for?" A pause. "Then, the stage concludes when the specimen's stress response cascade reaches threshold." "What threshold?" "Standard cascade threshold for soft tissue mobile specimens." "I can tell you with reasonable confidence that I'm not going to hit that threshold from this configuration," I said. "I've been in significantly more aversive environments on field rotations, and I know where my cascade triggers are. They're not here. The configuration you're running is calibrated for species where the primary threat environment is biological predator pressure, territorial competition, intraspecies violence. For those species, spatial confinement and low light are meaningful threat signals because they're the conditions under which things that want to eat you have an advantage. For Class 14 and above origin, the primary threat environment is physical, geological instability, atmospheric events, gravitational or thermal extremes. We don't wire spatial threat the same way because the thing that kills us on the secondary isn't usually something standing in the same room. It's usually the room itself. The floor opening, the ceiling coming down, wind shear at altitude. The configuration you're running tells me I'm in a small space with low light, and something is close to me, which is not a threat condition I learned to fear, because on the secondary that describes almost every working situation I've ever been in. The arm held position. If you want a genuine fear cascade from me, I said, I can tell you what would actually produce one. Active physical threat to someone I'm responsible for and can't protect. Structural failure in a confined space with no egress. A team member injured beyond what I have the materials to address. The specific helplessness failure mode, not the environmental threat mode. I'm not trying to interfere with your assessment. I'm trying to give you accurate data, because an accurate record of where my cascade actually triggers is more useful than a record that shows no response to a stimulus that wasn't calibrated for my threat model. Is any of that usable? The temperature started rising. The lights came back. The arms retracted to neutral position. The three Kethsorvani stood at the far wall and were very still for a period I timed at 4 minutes and 20 seconds. The subsonic register was active. I couldn't interpret it. The assessment will continue, the central examiner said. What's stage 6? Endurance capacity. What are the parameters? I asked. I want to know what you're measuring for so I can give you accurate data rather than optimizing for the wrong output. If it's raw duration, I'll pace differently than if it's performance consistency under extended load. The central examiner looked at me for a moment. Then it said, duration and performance consistency under progressive load. Thank you, I said, that's useful. Stage 6 was a long and demanding hour and a half that I will describe in the terms most useful for the record, rather than the subjective terms most accurate to the experience. The Kethsorvani ran an escalating cardiovascular load test on a resistance apparatus that descended from the ceiling housing magnetic resistance. Very well built, extremely smooth. The kind of quality that told me this apparatus had been engineered with precision and maintained with care. The resistance incremented on a schedule I identified as logarithmic in the early stages, and then shifted to linear, as the load approached what I estimated was my nominal maximum sustainable output. They ran me for 64 minutes on the resistance apparatus at escalating load, before I called out that I was approaching the sustainable ceiling, and asked whether they wanted me to maintain pace until failure or reduce to sustainable pace and continue longer. Maintain pace until failure, the central examiner said. I maintained pace for another 11 minutes before my form broke down enough that the data was going to stop being useful, and I said so. The central examiner noted the time and stopped the sequence. After that they ran a progressive pressure tolerance sequence, static load on the limbs, increasing in measured increments, monitored by sensors I couldn't see directly but could feel as slight warming at the contact points. The sequence ran longer than I suspected their standard version did, which I inferred from the fact that the central examiner ran it for 32 minutes, and then conferred with the flanking examiners before continuing for another 18 minutes to a threshold I reached, held, and was asked to hold further before they released the load. Then 2 cold immersion cycles, which I had warned them about at the outset, and they were right to run them anyway because the data is accurate and useful even if the threshold for a distress response was not reached. The immersion medium was cold enough that I was genuinely glad to get out of it at the end of the second cycle, which I mention because it's honest. At the end of the second cycle, the central examiner said, "The stage is complete." I dried off with the material they provided. They had anticipated this, which meant they had experience with immersion stages for soft tissue specimens, and I noted the material quality was good and said, "Is there a stage 7? All three examiners looked at me. "The assessment protocol is 8 stages," I said. "We've done 5.5 if I'm counting the abbreviated stage 5. 6 is done. What's 7? The central examiner's mandibles moved for a moment without producing translation output. "Stage 7 is environmental adaptation assessment," it said. "What does that involve?" "It is not typical for specimens to reach stage 7. I thought about that. How many specimens have reached stage 7? A pause. "In the current directorate record, across 1,412 assessed species, 11. And stage 8. 9 specimens have reached stage 8. What were the other 10 species that reached stage 7? The central examiner was still for a moment. Then, "The directorate record is not shared with assessed specimens." "Fair enough," I said. "What's stage 7? Stage 7 was an adaptive problem set, 5 tasks requiring tool use with instruments I hadn't seen before, without instruction, in sequence, under a time limit I could see counting down on a panel they'd finally positioned where I could actually read it, which I genuinely appreciated. It was the first time they'd given me direct access to timing information during the assessment, and I suspected it was either standard practice for stage 7 or a response to something in their observed data about how I was processing the experience. The instruments were clearly designed for a manipulator arrangement that wasn't mine. The grip geometries were built for something with 3 primary digits and a very different thumb orientation. What I was looking at was a tool design optimized for a laterally pinching grip, which is what a 3-digit manipulator with 2 opposing digits produces naturally. And what I have is a bilateral opposition grip with 1 primary opposing digit and a very different force distribution. You can work around mismatched tool geometry if you understand the functional intent of the tool, what it's trying to accomplish mechanically, and find an alternative approach to achieving that function with your actual anatomy. The first tool was a fluid management instrument, valved, with a pressure application point designed for the laterally pinching grip. I held it for about 15 seconds, assessed the valve mechanics, and found an alternative grip that let me apply pressure at the correct point using my index and middle fingers in an opposed configuration. That worked. The second tool was a calibration device requiring simultaneous adjustment of 2 independent parameters, designed for the 2 upper limb pairs to operate independently, but adaptable to a 2-handed approach if you held it the right way, and accepted that the sequencing would be slightly different. The third was a cutting instrument with an ergonomic handle that pointed the blade in the wrong direction for my hand orientation, requiring me to invert my grip and work from the opposite side of the cut, which was possible and produced the right result. The fourth was a fastening tool for a recessed joint. The approach angle was designed for a 3-fingered grip to insert at an angle my hand couldn't achieve, so I had to disassemble my access to the joint from the other side, which added time but worked. The fifth tool was a calibration device of more significant complexity, a 3-stage alignment sequence requiring the device to be held in a specific orientation, while each stage was executed in sequence, and the intended grip geometry made the second stage particularly difficult with my hand configuration, because the rotation required was in a direction that put my wrist at an awkward angle. I was working on it when the timer elapsed. I looked up. I was close on that one, 2 more minutes probably. "Do you want me to finish it?" The central examiner looked at the display and then at me. "The timer has elapsed." "I know, but the result on an incomplete task is ambiguous. You can't tell from an incomplete whether the failure mode was the time limit, the tool design mismatch, or my capacity. I'd rather you have a clear data point. If I can complete it in 2 minutes, that's useful information. If I can't, that's also useful." A very long pause. One of the flanking examiners moved to a different position for the first time in about 40 minutes. The subsonic channel activated briefly. "The task may be completed," the central examiner said. It took 2 minutes and 28 seconds. The alignment device clicked into its final configuration, with a tone I hadn't heard before: mid-frequency, sustained, clear. I set the instrument down and looked at the examiners. "Thank you," I said. There was a silence. "Can I make a note for your records?" I said. The central examiner did not respond affirmatively or negatively. "The tool grip geometries in Stage 7 are designed for a 3-digit laterally pinching manipulator," I said. "For bilateral opposition grips like mine, the second task and the fifth task require alternative approaches that add time to completion. I'm guessing my time on Stage 7 is longer than the 11 prior specimens who reached it, not because the tasks are harder, but because the tool geometry is a mismatch. If you adjust the grip inserts or provide an alternative tool set for bilateral symmetric manipulators, the Stage 7 data would be cleaner for specimens like me. It's a calibration recommendation, not a complaint." One of the flanking examiners made a short rising pitch sound for the second time. The central examiner was still. "We will note it," it said. Stage 8 was communication and language acquisition assessment. They played me a sequence of Keth-Sorvani language, not through the translation matrix but directly, in the full frequency range, including the subsonic components I'd been feeling throughout the session. The assessment was whether I could reproduce any elements and, if so, which frequency ranges and what accuracy. I could reproduce the components within my comfortable hearing range with what I estimated was reasonable accuracy. The specific sounds in the mid-frequency layer that I'd been listening to for 5 hours. The subsonic components were beyond reproduction. I could feel them, could tell when they were present and when they weren't, could detect some of the pattern variation but couldn't generate them. I said all of this. "I've been listening to the full frequency output throughout the session," I said. "The mid-frequency layer carries the primary semantic content, and the subsonic layer carries something else, relational information, maybe, or emotional modulation. The two layers are doing different jobs. The mid-frequency is the content, and the subsonic is the context." The central examiner stopped the sequence. "That assessment is accurate," it said. "The subsonic range carries relational and status information. How did you determine the functional distinction?" "The pattern of when the subsonic layer was most active," I said. "It correlated with consultation between you and the flanking examiners, and with decision points in the assessment, moments where you were processing something and deciding what to do next. Those are the moments when context matters most. When you were running a stage that was procedurally clear, the subsonic layer was quieter. When the data you were getting was outside your expected range, and you were deciding how to respond to it, it was more active. That suggested it was carrying the evaluative and relational content rather than the procedural." The central examiner's mandibles moved. The flanking examiner on the right made the short rising pitch sound again, the third time I'd heard it. "Is that sound an indicator of something specific?" I asked. "The short rising pitch sound. The other examiner has produced it 3 times. I noticed it correlates with moments of significant deviation from expected parameters." The central examiner looked at the flanking examiner, back at me. "It is an expression of a category that does not have a precise translation in the matrix's current vocabulary," it said. "The closest available rendering would be, a thing that should not be possible is happening, and I am watching it." I thought about that. "That seems accurate," I said, "from your data's perspective." "The assessment is complete," the central examiner said. "Can I ask you something?" A pause. "The assessment is complete." "I know. I'm asking anyway. In the 1,412 species your directorate has assessed, what's the distribution on Stage 7 completion? You said 11 reached it, but I'm curious how many completed the full task set versus partial." The central examiner checked its display. Of 11 specimens reaching stage 7, 3 completed the full task set within the time limit. 4 completed partial tasks. 4 did not complete any tasks. And the 3 who completed the full set, what class of origin? 1 class 9, 2 class 11. So I'm the first class 14 to reach stage 7, I said. Yes. And the completion of the elapsed task, that's unusual. The mandibles moved slowly. No specimen has previously requested to complete an elapsed task. I said. I sat with that for a moment. The room was quiet, which was different from the quality of quiet during the assessment. There was no subsonic background now, or very little. Whatever the examiners were doing, they were doing it without the relational channel, which I suspected meant they were past the point where context needed to be shared and were each processing independently. I have to say, I said, your assessment protocol is genuinely well constructed. The layered approach is sound methodology, and the adaptive problem set in stage 7 is a better cognitive flexibility measure than most species-neutral assessment designs I've encountered. The tool grip geometry problem is solvable. The stage 5 calibration gap for Deathworld origin is a significant data quality issue, but it's an addressable one. If you're planning to run more class 14 and above specimens through, the documentation on what actually triggers a cascade response in that population would save you several hours of non-productive stage 5 run time. The 3 examiners did not move. I'm also going to mention, I said, that the terminal assessment for my session is probably going to have a classification problem. I suspect the directorate's framework doesn't have an established category for class 14 origin specimens, with the full suite of baseline variations I've described. If you're creating a new category, the data from this session is your primary source material, and I'd encourage you to note the adjustment factors for each stage rather than treating my scores as anomalies in the existing class 6 through -9 human reference data. They're not anomalies. They're what class 14 looks like. If you file them as anomalies, the next class 14 you assess is going to produce the same confusion. The directorate will determine the appropriate record designation, the central examiner said. Of course, I said, it was just a methodological note. I was in the tractor field for approximately 4 minutes on the return transfer. The Scout was undamaged, and the docking approach corridor had been meticulously realigned, with our original entry heading precision maneuvering that told me something about the quality of their automated guidance systems. I got inside, ran a quick systems check, found everything nominal, and made myself tea, because the ship had been cold for 5 hours and tea was the most immediately useful thing I could do for myself. I sat at the survey console and wrote up my field notes while the tea was still hot. The ship's clock said 8:47. I have thought since about what they found when they opened the terminal assessment file for that session. 8 stages of data, all of it sitting outside the standard calibration range in every category they measured. A stage 7 completion with a note that the expired timer task had been completed on request, something that had not happened in 1,412 prior assessed species. 17 prior human specimens from Class 6 through Class 9, providing a reference baseline that the session data deviated from on every axis, in the same direction, by margins that were consistent with what a Class 14 origin would predict if you knew what Class 14 origin looked like. A specimen who had provided running annotation throughout, identified the protocol structure from internal logic before being told it, derived the morphological basis of an unfamiliar notation system from a working memory test, characterized her own fear response wiring with sufficient accuracy to allow the stage 5 configuration to be modified in real time, and offered twice to assist in constructing the new baseline category. I do not know what they filed in the classification field. It may still be blank. I have not followed up, partly because I don't have a clean channel to the Keth Sorvani Directorate, and partly because it's their record and their business what they write in it. What I know is that they were methodical and professional, and their equipment was excellent, and their 8-stage protocol was a coherent and well-engineered piece of assessment methodology that I found genuinely interesting. I know that their Stage 7 tool grip geometry would benefit from interchangeable inserts for bilateral symmetric manipulators, and that I documented this recommendation in my field notes. I know that their Stage 5 configuration is not calibrated for Class 14 or above origin, and that running it on such specimens is a waste of everyone's time, and that I documented that too. I know that the short rising pitch sound the flanking examiner made 3 times translates roughly as, "A thing that should not be possible is happening, and I am watching it." I also know that the T on the survey scout ran out sometime around what would have been Stage 3, which is the one material fact about the afternoon that I found genuinely inconvenient. My field notes from that session run to 22 pages. They cover the examination platform contour geometry, the lighting diffusion material, the magnetic resistance mechanism in the Stage 6 endurance apparatus, the translation matrix's frequency management approach, the symbol set morphological logic, the tool grip geometry mismatch and recommended correction. A full annotated reconstruction of the Stage 5 threat simulation configuration, with specifications for what would need to change to produce valid cascade data from Class 14 through Class 17 specimens, and my best estimates of the Keth-Zorvani language's structural organization, based on 47 minutes of listening to it through a translation matrix that was only rendering the primary semantic layer. I submitted them to the contractors collective as a Tier 2 encounter record, which is the appropriate designation for unscheduled contact with an unregistered assessment authority. The collective filed them under a designation I gather they hadn't used before. I went back to the Keth-Zorvani relay corridor and finished the survey rotation I'd been in the middle of when the tractor field found us, which took another 14 days and produced 46 core samples, and a full magnetometric map of the subsurface formation structure in the eastern relay zone. The secondary geological finding in Quadrant 7 turned out to be significant enough that the collective submitted it for a Survey Excellence designation, which carries a bonus. I used part of that bonus to upgrade the T supply on the Keth-Solin IV to something better than the standard issue field ration packets, which I should have done years earlier. I did not mention, in the Tier 2 encounter record, that at the very end of Stage 8, after the central examiner said the assessment was complete, I asked whether the directorate had ever considered adapting the 8-stage protocol into a bilateral exchange format, offering the assessed specimen a parallel assessment of the directorate's own cognitive and physiological parameters, so the data ran in both directions. I have a reasonable assessment battery for bilateral symmetric 6-limbed specimens with compound lateral array visual systems. It would need calibration, but the Stage 7 adaptive problem set logic would transfer directly. The central examiner had been very still for quite a long time after that question. The translation matrix had rendered the response accurately, I was certain of that. It said, "We will consider it." I have been thinking about that for a while.